Now,
Are we going
okay.
through every question? Sorry.
I don't. Right. So the thing is, we can go through every question if we feel we need to. However, what I'm not going to be able to do is do it so slowly that you can write down every solution. All right? Yes, Dave.
My sister was telling, I was asking about this one last night, and she told me it's an upside down picnic table. When did you learn that?
What's an upside down picnic table?
Cross multiply and then multiply the bottom.
What?
Oh, for this?
Oh, I see them picnic tables.
Okay, so, right.
I don't.
Again, I've said to you, I avoid shortcuts and names and things like that. So things get called lots of different things, you know. No, we didn't learn something called the upside down picnic table.
To go.
So if I say add fractions together, I would expect you, because it's the same with every fraction, whether it's algebraic or numeric, what do you do to add two fractions together? Make the numerators the same.
So you have to multiply them together.
So that's where people then go, oh, cross multiply or picnic table or whatever. You know, they come up with a name to help them remember. But I prefer to focus very much on the make the numerator or the denominators the same. All right? And how do you make the denominators the same? You multiply them by each other is the easiest way, isn't it? If it's just numbers, you can do it simpler. You can find the lowest common multiple. But when it's algebra, we just have to do it. Oh, all right. Sorry, my fault. Should have checked it worked. Right, so denominator's the same first before we add them. So this one is x. I've got to multiply it by the other one. 2 minus x. If I do that to the bottom, I've got to do it to the top. 2 minus x keeps it the same. So that's then 4. So there you've got the 4 over x, and we've multiplied it by that one. This side, we've got the 2 minus x, but we have to multiply by the x from the other one. So this then becomes 3x. Okay. We've then, when you write fractions, when you add them together, you have the same denominator, and then you just add the numerators, don't you? So 4 times 2 minus x plus 3x. So we've got it as a single fraction, but we need to now expand, simplify, collect like terms. Yes?
Can you please do the multiplication again? Like, what did you multiply it by? Multiply what by?
Like that.
So that side, I put over, multiplied the left side by, yeah? So it's like, if I've got to do 1/3 add 1/7, what do? We have 3 times 7 as the denominator there, plus, and we have 7 times 3, that side. I would just write it the same way around. Then the top, this would be 1 times the same thing, and this would be 1 times the same thing. So I've done the same with the algebra. So this one gets multiplied there, and then this one, the x gets multiplied. So what some people would say, you kind of cross multiply. Now the problem comes with, if you've got an equals and an answer, if you don't understand the whole we are making the denominators the same, you might misinterpret what's actually happening. Okay, so that's why I focus so much on the make the denominator the same.
So if it was an equal sign, we would just cross multiply and not multiply.
No, so we do the same thing. So what I've done at the moment, all I've done is make that fraction, adding fraction, one thing. Right? It doesn't change it if I say equals 7. I would just do equals 7. All right? I know what you mean. I'll do that one next. Right? So I don't have to do anything to the right hand side. However, if I had a different situation, which was 4 over x equals 3 and 2 minus x, all right, now the situation is still the same. How do you compare fractions? What do you want to happen?
The denominator should be the same.
The denominator should be the same. So we do exactly the same thing. We change it to 4 times 2 minus x over x times 2 minus x equals 3x over 2 minus x times x. Okay? Now, if we have, let me just get rid of this equals 7. The difference between this and this is when we are comparing fractions, I know that these two numerators have to be the same. Why?
Because they're equal on the bottom.
Because the denominators are the same. Yeah? So again with numbers, if I know that x over 3 is the same thing as 2 over 3, the x has to be a 2. So what I do then is I can say, well, if I know the bottoms are the same and I just need to sort the tops out, I can kind of forget that the bottoms are there. I don't need them anymore. So if I had this situation, because the denominators are the same, I don't need to worry about them. I can just kind of forget that they were there in the first place and just solve the top. Does that make sense?
Mm-hmm.
Now there's a different way to do it, which some people say, oh, you cross multiply. Okay, so you end up with 4 times 2 minus x equals 3x. You see how we get exactly the same thing? But one way is just doing all the work and showing why I'm allowed to do that. Alright? And this way, just doing the crossing, it skips out steps and just takes you straight to the end. Which is fine if you understand what you are and aren't allowed to do. Does that make sense? Okay? So, this one, there's no equals sign in this question. Therefore, I can't just ignore the denominator. I need it, as it's part of the fraction. And all I'm doing is simplifying it. There's no equals. So how do I simplify?
Expand the bracket.
Expand the bracket. Do I need to expand the bottom, the denominator?
No, because it's...
No, because it's not going to simplify. Alright, so I just make it 8, and this is a mistake a lot of you will go, 8 minus 7x over
But it's
x.
minus 4. Minus that.
But I've got, do you see how that can happen if you're not really thinking? 8 minus 4x plus 3x.
That's, isn't that minus?
Yeah, I'm telling you it's wrong, but can you see how someone would make that mistake? Yeah? So what is the right one, Ella?
X.
Minus x, yeah.
Yeah.
Okay?
Why would it be minus x?
Because I've got minus 4x, then I add 3x. Yes, go.
Would you expand it beyond?
No, so we don't need to. If you did, no problem, as long as you got it right. If you expanded it incorrectly, you make a mistake, but there's no simplifying going to happen. Just check.
So if it wasn't like, oh yeah, so I got really confused and thought that I would have to multiply the same thing for each like part of the fraction, but you only have to do that when it's, what type of fraction would you have to do that for?
You need to be more specific, because at the moment I have no idea what you're talking about. Without wanting to be rude.
I think like when it's one fraction, you have to like multiply the same thing to each term, right?
Yeah, so the top and bottom, and you keep the fraction the same value, yes.
Yeah. So then
Equivalent fractions.
if it's addition, then it's a separate.
But if it's subtraction.
So what I've done is I've multiplied both fractions to find equivalent fractions that. Do you remember actually yesterday with our simultaneous equations? Do you remember the ones that didn't have anything that eliminated? And I said, write a new equation by doubling everything. That would be called an equivalent equation. Same thing, so I've just doubled everything. So what I've done here is I've found an equivalent fraction. I've just multiplied the top and bottom by the same thing, so it's still equivalent. And that's a process used with all fractions, really, whatever you're doing. So I'm trying to focus on this one thing, so it's always the same. Anyway, let's move on. I don't think we've done that one, haven't we? We did that one before,
Yeah,
right? The show that question. Right, do you remember, I'm going to do a lesson at some point on show that questions, but it says here, show that 2x squared plus 7x minus 17 equals 0. In your test, you all solved it, rather than show how it comes. So you have to get to that. So do you remember I said you kind of have to forget that even exists, all right, and use the information that's given. So what is the information that's given?
That all the P equals the area.
The area of a trapezium is equal to 17. Yeah? And you go, how do I know what the area of a trapezium is? It's on the front page, yes. It's in your formula book. So you just plug these expressions in and you end up with what they ask you for.
And is that literally all you have to do?
That's it. It's always the same, every question. You use the information they give you, and then what a lot of you do is don't bother reading that line. Yes?
Quick question. For that, could we do it so that it's like you cut off the triangle and then solve the triangle and solve it?
You could do that if you want. Yeah. However you wish to do your trapezium. Yeah. Okay.
So it's a plus b and then h over 2.
That's
You said that the top would be a and the bottom would be b and the h would be the side.
Yeah.
But b is only one letter, but b is x plus 7. So how would you write that?
yeah. How would you put that?
Because B is x plus 7. You put it in brackets if you want it all to. That's why it's in
But
brackets.
it's already in a bracket. So is it like a bracket and a bracket?
So if I've got to do A plus B times H over 2,
No, h is on the
yeah, I would go 2x times A is x plus B is x plus 7 if need be.
Okay.
And that's
But if I've only got pluses, I don't need. Okay? I don't need the brackets. X plus 7 would just become what? So this would be 2x times 2x plus 7 over 2. And then expand the brackets, gives me 4x squared plus 14x, yeah, over 2. Divide it by 2, 2x squared plus 7x. But what have I not used so far?
The area.
Equals 17, equals 17, equals 17. And I want equals 0, so
Oh, go back up.
I'm not doing it so you can just copy it word for word. Alright, if you want to review afterwards, I said we've got to go through it quickly. I did explain this. We've done this one, you've already should already have this in your notes. This very question. Alright? If there's any little things you need to take down, fine, if you want to go through it afterwards. Okay? You get the principle. So really for that question, you're never going to get that unless you take the clue.
So it has to equal this.
It has to equal 17. You have to take that clue. Right. Solving it, fine. You all could solve it. Did you want to do question 3, Sky? Did you start with 3 or was it 4? It was 4, wasn't it? I think we did that. Those should be fine.
Wait, can we factor this fully 3e? Just real quick.
Okay.
Where's that?
Oh yeah.
Common factors?
4,
4.
e, and f.
How many E's?
2.
2. So that one's, they're all gone. That one, there's only 3 left. That 4 becomes a 5. That becomes a 4.
And f.
And 1 F. There's 1 gone. There's 1. And then I'm left with 5 e to the power of 3 minus 4. Yeah.
How come when there's a bracket on either side of the e squared and the e to 3, isn't it e6?
Say it again, sorry.
So since there's an e squared on one side bracket and e cubed on the other, shouldn't it be this? Where?
No,
Why?
because e to the power of 2 times e to the power of 3 is different to e to the power of 2 to the power of 3. Because that is e to the power of 2 times e to the power of 2 times e to the power of 2. So that's why they're different.
So,
Bailey?
how did you get the e squared? Because wouldn't that be e cubed?
Because both sides
No, because this has got an e squared, so I haven't got enough to take an e cubed out of both sides.
Yeah, but if you...
And one of them has some left
Yeah.
over.
I know, but wouldn't that be 3 left over, so that 3
It
goes
does
to
have
the-
So there, 3. 3's left over.
Isn't it bracket?
No, but how did you get the e squared on the other side?
Yeah, there should be
Because
they both have it squared.
Look, so I've got an e squared there. So that's the minimum. That's the maximum I can take out of that side. Yeah, I cannot take any more than e squared from that right hand side. Yeah. So I look at this one and say I need e squared, but what have I got left if I take a factor of e squared out?
3.
E cubed. Yeah? So I take the e squared from there, right? I have to take the squared out of that one, but what am I left with?
E cubed.
E cubed, which is there.
Yeah, but where did that e cubed come from on the other side?
What e cubed come from on the other side? Are you talking about here?
No, I understand how you got the e cubed there, but how did you get the 4e squared?
Because I've taken the e squared outside of the bracket. But the 4 comes from the fact that this is 4 times 4 and this is 5 times 4.
Oh, okay.
Yeah? Yes?
Shouldn't it be 5e cubed f? Because it's f 20e to the power of 5f squared.
True, yeah. We missed that, yeah. Yeah. Yeah, no, good. Just always check. Alright.
This number 4.
Can you do that one now?
I don't
It's a binomial. So it just shows
This is when we've done the splitting the middle term and we've got to this phase sort of and we have to factorise a second time. So we're now at a stage of doing it's 4 lots of x minus 5 times another x minus 5 plus, that's where we've got this splitting up of terms, 3 times x minus 5. So looking at both sides, is there any common factor? Yes, the common factor is the x minus 5. Alright, so a factor doesn't have to be one letter or one number, it can be an entire bracket. So I take the x minus 5 outside and I'm left with whatever I'm left with. Okay? So that bit's those two, the common factor gets taken out. But then I have to sort this mess out. So I've got x minus 5 times, or 4x minus 20, so that's 4x minus 20, but plus 3, so I've got 4x minus 17. Yes.
How come we can't just cancel the x minus 5? Because we're factorizing.
Well, alright, well what's your justification for just cancelling it? Are you just cancelling because I've got 2 of them?
Yeah.
So that's not really a justification for doing it. You need a justification. What allows me to cancel something out? When you do the inverse of it. Yeah, that's the only way of cancelling something. What's the inverse of adding?
Subtracting.
What's the inverse of multiplying?
Dividing.
So I can only cancel something out if I've got a divide or a subtraction or the opposite of what I've got. I've got no opposites of anything. I've got this, add this. If anything, I've got more x minus 5s. I can't just get rid of them. I'm adding them together, yeah?
Yeah.
All right, that's question 4. 5 you're easy with, yeah?
Yeah.
Factorising, double brackets. Rearrange the formula, you're good with that now?
No.
No?
No.
We've done that, a lesson on that now though.
Yeah. Yeah, I thought.
Make x the subject. So do you remember what I said? Start with x and figure out what has happened to x, and then undo that.
Which question is this? 5B.
So what has happened to x?
It's been squared.
It's been squared,
multiplied by b.
multiplied by b,
And added to a. Or subtracted to a.
subtracted from a. Now that's where it becomes a little bit more abstract to think about it. But this is where we need to use our sort of knowledge of the processes. So what do I want? So if I've got minus bx squared, that's a bit messy. I don't want minus my x. So what's the first thing I should probably do? Instead of a minus bx squared, let's add the bx squared on so it's not a minus anymore. So if I add the bx squared to both sides, I get y plus bx squared equals a. Now it's a bit nicer. Are you happy with I've done that?
Yeah.
So I'm trying to get rid of any negatives as best I can around the thing that I want to make the subject. Now I can get on with it. So now it's x squared multiplied by b, add y. So I've got to reverse that. So what's the first thing I have to reverse?
Subtract the y.
So I have to subtract the y. So if I subtract the y from both sides, I get a minus y. Now it's x squared times b. So I have to divide by b. So I'm going to divide by b. Gives me x squared is a minus y over b. And then we square root.
Oh, we have to cover everything.
Yeah, so remember we talked about this the other day. Yeah.
Can you look at A, please?
Did you send me an email requesting it?
No.
No. There was just one thing. I only mentioned it to Kiara on her paper, but with it, to tell you all now, what should you technically include with a square root? Nope. You don't need that.
A square.
No? Plus and minus. We ought to be saying we want plus and minus. Now, Kiara said, but why do you bother? Because surely when you do the square root, you then say, I want the plus and the minus. But there is a case, when we're doing formulas especially, right, maybe the result, we only want to keep the positive. Because let's say it's an applied formula, it's got to do with volume, area, time, distance, whatever. We would say we only wanted the positive root. But if we're allowing both, we ought to say we're allowing both. Just a small technicality. Yes?
Is there a difference between just doing like that versus having the tail?
So you're saying if I didn't put the little tick.
Yeah, would that matter?
So if you just did that,
Yeah.
I'd know what you meant.
Okay.
Yeah, I wouldn't penalise you for not having that. You know. But I mean that's the correct notation, but I wouldn't worry about it. Alright. The reason why
That's your final answer, sorry.
Yeah, that's it. That's your final answer. The reason why I'm going through this relatively quickly, I'm aware that I do not want to miss a whole lesson on recapping on that simultaneous equation stuff. I want to give you at least some time to have a few practices on those as well. Right? These are the famous ones. You were just talking about this one. So what do we do when it's a power outside of a bracket?
We times them together.
Okay. But if it's a 3,
Oh, we make it 3 to the 4.
so it's 3 to the power of 4 times a squared to the power of 4 times b to the power of 4. The 4 gets applied to all of them. So then we've got 3 to the power of 4 is 81. A to the power of 8. B to the power of 4. That's it. Okay. Now this one tests your understanding of what a fractional power means. Do you remember? Square roots. Okay. Now, when we deal with powers that are square roots, everyone, you can't square root a variable that you don't know what the value is. Okay, so you leave it as a power. If it's a number, you can square root. So for instance, this is what they're checking. So I would do 9 to the power of a half, because 9 is a number. I'd be doing square root of 9, but I would be doing c to the power of 8 and keeping it as a power.
Yeah.
The reason is, the square root of 9 is 3, right? Technically, we could be saying it's plus and minus 3, but they're not worrying about that at this level with this type of question. And then it's c to the power of 8 times a half is
3, 4.
4. Okay, so that's why you have to do it differently for the number and for the, because if you wrote 9 to the power of a half, that's fine, but you need to actually process that. You need to say that that's square root and therefore it's 3. Yeah.
Can you just put 9, do like square root 9c8?
No. Because it says simplify. And square root of 9 is much simpler written as 3.
Yeah, like do it and then, okay.
Yeah.
So just to make sure I got this right, the square root is basically the same as like a dividing. So you divide the indice inside the square root by the number outside the square root. So like a square
You mean
root
this?
is 2.
Well, I'm still multiplying, so it's about saying if I multiply by a half, it's the same as dividing by 2.
Because when you multiply by something smaller than...
Wait, doesn't a fraction mean you add a square root on the one on the bottom and you multiply like
No.
the top?
So what you're talking, there are certain rules. Put your hand down, I'll come back to you. Remember. Certain things, so for instance, if I've got x, any number, and I do a half, that's x square root. If I've got x to a third, it's x cube root. If I've got x to the minus a half, the minus makes it 1 over the square root of x.
Yeah.
If I've got x to the minus 3, it's 1 over x to the power of 3. The minus makes it 1 over. So,
Oh no, I meant. So the bottom number, so the 2 for the first one.
oh right.
Is the number.
That's the root.
square
Okay,
root,
yes.
And then the top one is what you.
Oh, okay, yeah, no, sorry. Yeah, so if I've got x to the power of 3 over 5,
It'd be square root to the 5 and cubed.
yeah, and I can do it either way round. So I can do the 5th root and then cube it, or I can do cube it and then the 5th root. Yes. Okay. 7. Right, again, now we should be much more capable of doing this one, having talked about it at the beginning. We're adding fractions first, and then it's been equal to 1. So, what do you do when you have to add fractions?
You make
the bottom, you multiply the bottom.
So you make the denominators the same. So the denominators will be x plus 1 times 2x minus 3 all over, well, that one will be 3 times 2x minus 3 plus, this will be x plus 1 2x minus 3, and this will be 2 times x plus 1. All of that still equals 1 at the moment, because I've not done anything with the 1. Alright? What do I do now? Same thing as before. Add the numerators. Should we expand them as we're going? So I've got 6x minus 9 add 2x plus 2 all over, and I'm just going to leave it as x plus 1 2x minus 3. The reason why I'm not expanding the bottom is because it's in factorised form, and if I'm going to be able to simplify at the end, I need it in factorised form. I don't want to get rid of that. So then I've got 6x plus 2x is 8x, minus 9 plus 2 is minus 7, and all of that is over x plus 1 and 2x minus 3. Now I'm looking at this and saying, is there any way of factorising that to get me a common factor with the denominator? And no, there isn't. So I don't need to do any more. Right? That, though, is equal to 1. So, now what do I do? Jen?
Oh, never mind.
There's 2 ways to think about this. Yes, Taylor.
Should I multiply the denominator and then by 1?
You could do that. So, like I said, there's 2 ways to think about it. Alright? So, I think the one Haley's saying is, if I've got this, the numerator has been divided by that to equal 1. So one way to think of it is to say, well then I multiply by the denominator and gets rid of the divide by the denominator, yeah? So that's the inverse operation route. Does that make sense? That's one way to do it. The other way to think of it is, if I'm comparing fractions, what do I do?
Aren't you going to FOIL
Make
the
the
bottom?
bottom
No.
the same.
Minus the 1 on the other side.
No, no.
Oh,
I
zero.
don't want the minus 0 in this case. That will just minus 1 make. I don't need it.
You get 1
Okay.
over 1.
Well, what do I do, sorry, if I compare fractions? Make the denominator the same. How do I make this denominator x plus 1 over... How do I do that?
Times it.
Times the top.
Ah.
Okay, now I'm lost.
Yeah, me
Right.
too.
So I've multiplied,
I don't want his hair.
again, top and bottom by the same thing, but with the 1. Now, yes, go on.
Why didn't you multiply the top of the 8 by 7? I thought you had to multiply everything.
No, so do you remember what I said? If I want a common denominator, I want the denominator the same. This one already has a fraction sorted. I need to convert 1 into a fraction with the same denominator. So it's like doing x, if I simplify it, x over 6 equals 1. There's 2 ways to do it. Alright? I can multiply by the 6, or I can say x over 6 has to equal 6 over 6. Now I know that x equals 6. Yeah? Because the denominators are the same. Do you remember we talked about before? So I can do it like that, or I can just say multiply both sides by 6. But if I do that, I end up with the same thing. So what I've done, just on a what looks like a more complicated level, I have just taken this denominator and multiplied top and bottom of the other side to make the same denominator. It's a bigger, more complex denominator, but it's the same process.
But it doesn't matter which one you use.
What do you mean, matter which one I use?
Well, like, they're both correct.
No, yeah, both methods. Yes, absolutely fine. Yes.
So then would that one
The right-hand side, yeah.
would that just be the answer? You don't have to look.
No, so I'm not finished yet, am I? If I've done it this way, I've used my common denominator method. Do you remember we said the first one we did?
Equals.
If the denominators are equal, the numerators have to be equal. Therefore, I can just forget the denominators now exist. Alright? Now obviously you're not able to just rub out like that, so I wouldn't do it. What I would do if I were you is rewrite the next line as, well therefore 8x minus 7 equals x plus 1 times 2x minus 3. Okay? Make sense? Now, again, you're all head down and writing, but let me just show you something. So if I were to go back to what we had initially, can you see how I would end up with the same thing, if I have the 1 there, by just multiplying all of that to that side? You end up with the same thing. However you want to think of it, you end up with the same stuff. Alright? So we're going through both, but you choose whichever one. What is going on?
Would that be the answer?
No, not finished yet, are we?
No.
Then don't you FOIL it?
I don't know what I'm doing.
Now we can
So,
FOIL.
There we
Yes.
go.
That makes Ella happy. So we've got 8x minus 7 equals 2x squared minus 3x plus 2x. So I've done that, minus 3x. Done that one.
No.
And finally it's minus 3, yeah? Got that one.
I did it differently.
Yeah,
didn't I?
whatever order you wish to do.
'Cause I
Fine.
foiled it like before and then put it
Okay.
next to the one. Is
But
that
then-
still correct?
Yeah,
'Cause I got the
yeah,
same
it's fine. Yeah. You can foil at whatever stage you wish to do it. It's just, you know, it wasn't necessary to do it when you said you can do it, it's fine. So what do I do now? So I've got 8x minus 7 equals 2x squared minus x minus 3.
Can you add the 7 to the...
Okay, add 7 to both sides, I'm happy with that. 2x squared minus x plus 4, because I've added 7.
X1.
Then,
Then you...
so we've got a
add X.
quadratic, now what do we want?
Foil.
No,
No, we've already done
No,
the
sorry,
foil.
Formula.
factorize.
Ali, what do I want when I've got a quadratic? You said it, that's why I'm asking you.
0.
0. I want the equal 0, don't I? So I subtract 8x and get 0 equals
oh my
2x squared minus 9x plus 4.
So X.
Wait, you can't just like inverse.
So you just get rid of 8. Oh, you put it, never mind.
Yeah, so I subtracted the 8x. Right, are we finished?
No. Then you put it in the
How do you know
little,
that you need a 0? Like,
then you put it in the little thingy.
What about
Quadratics, how do you solve a quadratic?
You don't use the formula.
But before you can use the formula, it has
You
to
times
equal
the 2 by
0.
0. To solve a quadratic, you can only solve the quadratic when it equals 0. So you have to set it up to equal 0. That was the that's what I told you right from the beginning.
But even without using the formula, can you solve
It has to be set up to equal 0. The whole point, do you remember the whole null factor law? Something times something equals 0. Has to equal 0.
Yeah.
Jasmine?
So, okay, so how do you know, like, it's a quadratic? It wouldn't like
It's got a square.
Okay, cool.
Yeah.
Where's the quadratic?
It's got an x squared, it's a quadratic.
Do we work it out?
Alright, so what would you do to now solve this?
You have to find A, B, and C for the
Okay, so,
formula.
right, so you could use the formula. We could try and,
Can we graph it?
we could graph it. We could try and factorise by splitting the middle term. We could use our calculator to solve whatever method you want. Do you know how to remember how to use your calculator to solve it?
I can use the graph part.
You can use the graphing bit, fine. There's the polyroot finder thing. Do you remember doing that one?
No. Is that really good?
Should we have a go at? Let's have a go at split and middle term.
Yeah.
Okay. So what do we do? What's our method? Taylor?
You times the 2, which is A, by 4,
Okay.
and that equals 8. And then you think to yourself, what makes 8? So 2 and 4 make 8. And 1 and 8. And then, oh look!
But they've
One
got
and
to
eight
be
equals
both
9.
positives or both negatives.
Oh.
Because we have a negative 9, they both have to be
Positive.
negative.
Negative.
Otherwise, if we added them together, they wouldn't give me a negative.
So now we see that that works. So then you go 2x.
So we've got 2x squared.
Subtract 8x. Subtract 1x equals 4. Plus 4. And then you split it in the middle of the two x's, and that equals 2x bracket 2 what? X subtract 4 bracket subtract I think. Yeah. 1 bracket x plus 4. x subtract 4.
X plus.
And then you take away one of them. And that equals 2x. Subtract 1.
And don't forget, all of this had to equal
0.
I'm so bad at splitting the middle terms.
And I had to
Right.
learn it last
So
week.
does x minus 4 equals 0?
So either x minus 4 equals 0, which means x would equal 4, or 2x minus 1 has to equal 0, which means x equals 1 half. Okay? So there's your sum. Okay? Lots to that one. That's a big, long question.
I'll show my sister.
Could you also do it with the
I did that.
with the formula?
Yeah, you could solve it with the formula. Yeah.
But oh no, I didn't get
Wait, so
that.
when you see a
Yes, I
question,
did. Yes, I did.
I wrote that.
Apparently I didn't finish this.
No, I don't think many people do. Okay, moving on. We are running out of time.
Shorter than you.
Right. I'm just going to go through a bit quicker. So this one, simplifying fractions, you need to have it in what form?
Factorization.
Factorized. So the top factorized is
2x minus 5 bracket 2x plus 5.
okay. Difference of two squares. Did you spot that? 4x squared is 2x all squared. Notice what we said.
Oh, I got this question right.
I got it right, but I didn't do the difference of two
I didn't write,
squares.
what did I write?
The denominator needs to be factorized. Now the clue with it is one of the factors is going to be what? 2x plus 5 or 2x minus 5. It's going to be, otherwise they would give you a question that is a rubbish question. Right? So if we factorise, how are we going to factorise 6x squared plus 13x minus 5? What do we do? Split the middle term again. So 6 times 5 is 30. Things that multiply to make 30 add to make 13. 2 times 15. It's got to be a minus. That's a positive, so the bigger one has to be the positive. So minus 2 times 15.
Wait, why 30?
6 times 5.
Right, oh,
And
Yeah.
that equals 13. So
Right, so we've got 6x squared minus 2x plus 15x minus 5. Split it, so we've got 2x times 3x minus 1. Right? We probably don't need to go any further at that point. If I'm confident in myself, I know, well, there's my second factor, because I'm going with the other one is likely to be plus, well, it's going to be 5 times 3x minus 1. So the second, so I've got 2x plus 5 and 3x minus 1. So that's what goes up here then. So we've got 2x plus 5 times 2x minus 5, and underneath 2x plus 5 and 3x minus 1. So which factors cancel?
The first one.
First one. So I'm left with only 2x minus 5 over 3x minus 1. What should we not do at this stage?
Factorize.
We can't factorise. We wouldn't be able to, but I'm just thinking of a real common mistake that...
divide.
No. Not even that. I'd be happy if you tried to divide, but it wouldn't be. But what might some people do?
Oh,
Just cancel the x's. Yeah. I mean, would you believe if I said, would you understand, sorry, not believe, if I said someone might write minus 3 over 2 as their final answer?
no.
I probably would have done that.
No, could you understand? Not would you do it? Could you? What would they have done? So they've crossed the x's out. 2 minus 5 is minus 3, and 3 minus 1 is 2.
I should see myself.
All right. So it's very good to think about those kind of mistakes. So you go, yeah, we talked about that one. I'm not going to do it.
I have a question.
Oh, so
Yeah.
the final answer is.
If we were to write it out, technically, wouldn't it be x plus x minus 5 over 3, over x plus x minus 1?
Well, that's another way of writing it, but
No, but couldn't you then take away 2 x's? I know you don't need to, but why? No, like you're not supposed to, but why?
but that's the same thing as just crossing 2 x's out and making 1 x on the bottom. Because remember, we're not getting rid of things. Remember I said with Jen, you are doing an inverse. All right?
Oh wait, I get it now. Sorry, I just remembered
Everything
something.
except how you get the first thing.
Right. I'm not going to do this one. I think you should be capable of it now. What do you do?
Keep the
Makes
base.
the denominator the same.
Okay, now, everyone, just the one thing I will say on this one. There is a long way and a slightly shorter, less complicated way. The same rule applies. What do you do? Fractions? Make the denominator the same. What's normally the case? How do you make the denominators the same?
Multiply together.
Right, multiply them
But you
together.
can't.
You can.
Ow.
You can do that, but you don't need to. Why is that?
Because
If you are really with it, you would spot that.
Cancel.
No?
No.
never Jen.
If you're with it, you might go, well, that's x plus 2. If I were to factorise this side, what do I get?
X.
Yeah, 2x.
2x minus 6.
Actually, is this the right one? So it would be x minus 1 and x
Minus 3.
minus 3. Okay, let me think. All right.
Maybe not.
This one would factorise 2. 2 times x minus 3, yeah?
Yeah.
Do you get that?
Yeah.
So I can just change that to...
I got that back.
Now, if you are really with it and you spot that, I don't need to multiply all of this by all of this. I only need to multiply this one by 2,
Or 2.
because the 2 here, and then this one I multiply by x minus 1.
See, if you did that.
So now I have the lowest common multiple for the denominator. Alright? Now if you didn't do that and you just multiplied everything, you get to the same answer eventually. You've just got more complicated stuff to deal with, that's all. Alright?
Quick question.
Yes.
When we multiply the denominator of another, like we multiply to like make the same denominator, do we always have to multiply the top?
Yes, because it's equivalent fractions. You've got to do top and bottom together. Alright, so the reason is I've done it like that is it just simplifies the top. Otherwise, I would end up with 5 times x squared minus 4x plus 3 all over 2x minus 6 times x squared minus, sorry, that should say minus, 4x plus 3 minus x plus 2 times 2x minus 6 all over 2x minus 6 times x squared minus 4x plus 3. Okay? So this is fine. This is fine and simpler. That's all.
Oh, wait.
You see it?
Do you foil before you expand?
Foil before you expand.
Because if there's 2 brackets.
I know, but I created them, didn't I? I factorised. Why would I foil to put them
Oh, they're
back?
both?
I don't need to at this stage.
Oops, that is.
Right, so at this stage, same thing with all fractions. Then you just subtract the tops. You have to expand these brackets, then do subtraction. Do I need to expand there? No, because actually what I want to know is if there's any common factors in the numerator that I can cancel out on the denominator. So I don't want it foiled yet. I don't want it expanded yet. But do you get how I can just have a simpler denominator? That was part of that question. So you would take a minute or so longer to do this version. And that builds up by the end of a test. Okay. Oh, this one we've done already. This is obvious. We did these yesterday. Right. That one, same idea, same denominator, set it up. So this one, same denominator, it's the same with all of them. Okay? Right, should we go through?
Yes.
We're back to only 5 minutes again to do this one again. But thanks to Miss Harrison, I was having a quick chat, she was saying she did this with her class. Got a slightly different way, if you want to, might help you understand one point. I'll try it and we'll see. So again, over to you, you lead it this time. What do I do first? Hayley.
First, you write it out fully. So you write the 5 minus the third x, bracket, bracket, 5 minus third x, bracket, bracket, equals y 20. Then you FOIL.
FOIL. So 25 minus 5 root x minus another 5 root x plus x.
Yeah.
You're all happy with that now, aren't you? Yeah? Because minus x, minus root x times minus root x is just plus x. Collect the terms. 25 minus 10 root x plus x equals y minus 20 root 2. Right, here's where I change it slightly. So I'm going to collect like terms. So I know the 25 and the x are like terms because they're just numbers, right? So I've got 25 plus x minus 10 root x equals y minus 20 root 2. Okay, so now what I do is I think, well, the 25 plus x, if I just look at the structure of the two sides, the 25 plus x equals y. So 25 plus x equals the y bit.
Why?
Oh, I get it.
Because of the structure.
Same place.
Yeah.
Because 10 minus x
Yeah, but
is
then
the
that
20.
doesn't work.
And then, right, so we're not quite finished. And then the minus 10 root x, or actually what I'm going to do, because they're both minuses, I'm just going to say 10 root x has to be the same as 20 root 2. So I can say that 10 root x equals 20 root 2.
See, why are we assuming that though?
Well, we're assuming it because I've now got it in both sides. I know they are equal. Alright, I know they're equal. I know the yellow bit is a constant term in terms of it's an integer. Has to be an integer, there's no root there. Alright, so I'm comparing like terms. So this is an integer, that's an integer. Because of the structure that I've got, one thing minus another, I can say, well, the 25 plus x has to be the same as the y. Otherwise, I'd be changing my structure if it wasn't the case.
But what if you, because sometimes when you FOIL, like your structure isn't the same as other people's.
No, but once it's all collected together, it will be the same.
But I mean the order. Like
Yes, but once I can rearrange things. It's not about the order in which it's in, it's about the type of term. This is an integer term. X will be a number, yeah? Not a surd. So I've got, do you remember the whole rational, irrational thing of surds? This is just an integer value. 25 plus x is an integer value. Y is an integer value because there's no roots by it.
But isn't
The 10 root x is a surd. That therefore matches to the 20 root 2. They have to be the same.
will that always be the case if there's a third on either side?
If there's an equal sign, I know they're equal. Yeah. If that wasn't an equal sign, I think that's the thing. You're forgetting the significance of that equal sign.
But couldn't. Why are we? I just don't understand how we can just be like, oh, those must be the same because they look the same.
Because this will never be an integer value, will it?
No.
20 root 2 is not an integer. Therefore, it will never be a part of the y. Therefore, it can never be part of the 25 plus x. Leah, sorry.
Wouldn't it be negative 20? and
Right, the
negative
reason why I've not put negative is because they've both got negatives.
Oh,
So I can just treat, yeah?
If I were to do, but if I had like a negative 10x with the
10 root
x,
x.
yeah. And I put the 25 with it, so it'd be 25 minus 10x. Wouldn't then it be a different number than the 20 the third thing?
But the 25 minus whatever root x, they will never go together and simplify to be one thing unless I turn it into a decimal. If I turn both sides into decimals, but I'm not doing that, so they will never go squashed together to make one thing.
Okay, so if we see a third on one side
Yeah.
on either side of the thing.
Exactly, because I think the significance is the equal sign. You're being told they're equal, so bits have to compare. Did anyone kind of get on with that then? So this was a different way of thinking about it. So we are now going to solve. I can't solve that simultaneous equations because I've got x and y. I've got two unknowns. This one has one unknown. So what can I do now? Do it in a slightly different way to we did yesterday. But I've got 10 root x's and 20 root 2. So what can I do first? Jeff? Put a 2.
Oh, it replaced the x with the
Well, that's not going to be right, is it? That would be 10 root 2 is not 20 root 2.
You changed the third on the right.
Right, so that's what we did yesterday. But what I'm going to say is, right, well, if I've got 10 times something and 20 times something, why not divide both sides by 10? So then I've got root x has to equal 2 root 2. Yeah? Does that make sense? Now, I've still kind of got to do the same thing I did yesterday, which is, well, root x, can't do any more with that, but that equals, well, I have to make that a third with no rational bit. So 2 is root 4. Don't crash, don't crash. Root 4. So 2 is root 4. So times the root 2. And when you have 2 thirds, that then becomes root 8. So therefore, root x is root 8. Therefore, x has to equal 8. Now I can put it into here. So 25 plus 8 equals y. So y equals 33. All right? So slightly different way to think about it. Not amazingly different, but slightly different. Yes?
So how is the 2 from 2 root 2? How is that from 4?
What's root 4?
2.
2.
Oh.
You've got to be happy to write numbers in different ways. If I said to you express if I said express 4 over 2 as a different number, what would you say? 4 over 2. 4 divided by 2 is? 4 divided by 2 is 2. There's different ways of writing it. So. Okie doke.